So if you're a little bit test-wise, you should probably be able to guess this even if you don't understand why. The answer is this, but let me explain why. So what we'd like to show is that if we're given a function f of n that is in big theta of g of n, that we can turn that around and also infer that that means g of n is in big theta of f of n. So the way we're going to show this is to go back to the definition of big theta. So here's the definition, that there's some constants c1 and c2 bigger than 0, and an n0, a threshold n0, such that f of n lies between c1 of g of n and c2 of g of n for all n bigger than the threshold n0. We can infer from this that by dividing through this equation, dividing through by c1, which is a positive number, we get a new set of inequalities, like so, where g of n is now sandwiched between 1 over c1 of f of n and 0. We can do that same trick again, dividing through this equation by c2, and we see that 1 over c2 of f of n is less than or equal to g of n. So we can combine these two facts to show that g of n is sandwiched between 1 over c2 of f of n and 1 over c1 of f of n, like so. Now notice that this 1 over c2 and 1 over c1, those are just constants. So it's equivalent to say that this 1 over c2 is just a constant. We can rename it c1. And this 1 over c1 is just a constant. We can rename it c2. And this is exactly the definition of big theta. So we can infer from this that g of n is in big theta of f of n.